Okay, the next part of the video lesson is predicting the outcome of reactions. And you might be given a question about a reaction such as, will zinc react with aqueous copper ions? Or, for example, you might be given, will silver react with aqueous magnesium ions? So that's what we mean by this sort of reaction. It's a redox reaction, and we have to predict yes or no whether the reaction that we've been given will happen or not. So there are several ways of doing this. One of which is called the anti-clockwise rule. It's a mechanical way. I prefer another way, a more intuitive way, but let me go through the mechanical way with you first. So if you don't get the intuitive way, you can always use this as a fallback. So let's use an example as we go through. So that first question that I listed out there, will zinc react with aqueous copper ions? There's our question. So this is going to be zinc solid, and aqueous copper ions are going to be Cu2+ ions in solution. Right, so is the zinc solid going to react with the copper ions? That's the question. And the first thing we have to do is we have to write down the two half equations for the redox reaction. Okay, so as far as zinc is concerned, let's put zinc in blue. Okay, so as far as zinc is concerned, it's going to be zinc, the half equation written in the reduction direction is zinc 2+ aqueous is going to accept 2 electrons, and you're going to end up with zinc. And then if we do the same for copper, let's do copper in red. Okay, and in the reduction direction we would start off with copper aqueous ions, and they would also accept 2 electrons to form a copper metal. Okay, so we've got the two reduction reactions down. So at least the forward reaction is the reduction reaction for both zinc and copper. Then what we would do is we would write down the electrode potential. So the electrode potential for zinc, so you look at your electrochemical series and you see it written like this: zinc 2+ to zinc solid, and that electrode potential you'll read off electrochemical series is minus 0.76 volts. And if you did the same for copper, you would see copper 2+ and copper given an electrode potential of positive 0.34 volts. So that's what you would read off the electrochemical series. And then what you have to do with this anti-clockwise rule is you have to put the half equations, put the half equation with the more negative electrode potential on top. Okay, so I'm going to move back to blue for zinc. So the one that is more negative is the zinc. So we're going to write that half equation on top, and they're both written still in the reduction direction. So we have zinc 2+ aqueous plus 2 electrons it's in equilibrium with the zinc solid. Okay, and the other one is going to go on the bottom. So we've got copper 2+ accepting 2 electrons in equilibrium with copper solid. Okay, so that's that step. Now the next step, which I'll do in purple, is to draw on these anti-clockwise arrows. Okay, so you go from the product of the top reaction to the reactant of the top reaction, like so, and then the bottom arrow also going in the anti-clockwise direction goes from the reactant of the bottom half equation to the product of the bottom half equation. So you see we've got two anti-clockwise arrows there. And then what you have to do is you have to look at the non-pointy ends, the starting ends of the arrows, to work out if the reaction would happen. So if we looked at the starting end of the arrows, we've got zinc and we've got copper 2+ ions. So, and then we refer back to the question. What I've drawn in the boxes is what would react in this when these two half equations were put together. So in the question we've been asked about zinc solid. Does that react with copper ions that I've put in the squares there? So you can see that this will react. Zinc solid will react with copper ions. Okay, so yes is the answer to this question. Okay, so let's go through that once again with a different example. But this time let's use an alternative question. This time let's say, will silver react with aqueous magnesium ions? Okay, that's our question. So you'll remember the first step is to write down the two half equations. Okay, so the two half equations, first of all, silver. Okay, if we look at an electrochemical series, we've got Ag+. Well, let's write it down as a half equation. So it's Ag+ plus 1 electron in equilibrium with silver metal. And as far as magnesium is concerned, we would have magnesium 2+ ions plus 2 electrons in equilibrium with magnesium metal. Then we go to our electrochemical series to look up the electropotential of silver, and we would find this sort of listing for silver. It would come out at 0.08 volts. And for magnesium, magnesium 2+ magnesium metal would come out at minus 2.38 volts. Okay, so if you remember the next step is to write out the two half equations, one on top of the other, with the most negative one on top of the other one. So the most negative one is the magnesium. So let's write out the magnesium. Let me do that in red. Magnesium, and also I'll write it down here to give me some space. So the magnesium 2+ plus 2 electrons is in equilibrium with magnesium solid. And then let's write the less negative one, in this case positive one. So you've got Ag silver ions in solution, and they might take an electron. If they did, they'd be in equilibrium with silver solid. Okay, so now we have to write on anti-clockwise arrows. So we go from the product in the top reaction to our reactant in the top reaction. That's in the anti-clockwise direction. And we do the same for the, well, the opposite actually, for the bottom reaction. We go from the reactant to the product. And so what we find that will work is magnesium solid and silver ions. So those, the starting points of the arrows, the species at the starting point of the arrows, the ones that I've put in green squares there, are the ones that will react together. Right, so then we have to refer back to the question. The question was asking us about silver solid. Will that react with aqueous magnesium ions? So Mg2 plus ions, aqueous magnesium ions. And so we've got magnesium solid, not magnesium ions, and we've got silver ions, not solid silver. So the question, of course, is no. The answer to the question is no. The silver will not react with magnesium ions. So the last point to make about predicting the outcome of reactions, these redox reactions, is to not assume that the reaction is going to work. You're just as likely to be given a reaction that won't work in a question such as this. Yes, and you can also use the anti-clockwise rule to find the cell potential. And if I can just ask you to cast your minds back to remember the equation for the cell potential. And what you'll remember is that the standard electrode potential for the cell is the electrode potential right hand side take electrode potential left hand side. That's the standard equation, and I actually prefer to remember it like this. For the reduction reaction minus the electrode potential for the oxidation reaction. And for the anti-clockwise rule, you can write out the same equation such as this. The electrode potential of the half equation that you write on the bottom, take the electrode potential of the half equation that you write on the top. And that's when you've gone through the process of putting the most negative half equation on top and the one with the less negative half electrode potential on the bottom, and in which case you come up with this equation here. So let's have a look at an example. If you were to look at an electrochemical cell consisting of zinc and copper, as we've seen quite a few times, the zinc would go on top because that's got the most negative electrode potential, and that, if you remember, is minus 0.76, and the electrode potential of the copper half cell is 0.34, so that would go on the bottom. So the electrode potential of that cell, according to this this version of the equation, would be the electrode potential of the bottom reaction, which would be 0.34 minus the one on top. And as we've worked out before, that comes out at plus 1.10 volts. And just for the sake of completeness, why don't we do one more example? Let's do an example of magnesium and aluminium. And when we look at the electrode potentials for magnesium in an electrochemical series, you're going to find that it's minus 2.38, and if you looked up aluminium, you'd find that as 0.8, and so the magnesium goes on the top and the aluminium goes on the bottom. So the electrode potential for the cell would be the bottom value, which would be aluminium, which is 0.8, and then you would subtract from that the minus 2.38 of the magnesium, which is going on the top there with the anti-clockwise rule, and then that all comes out at positive 3.18 volts. So quite a nice voltage for that particular electrochemical cell. So that's another way of working out the cell potential using the anti-clockwise rule and this version of the electrode potential for the cell.